To greet you, matric students. I'm just making some videos for revision as you are preparing for your exams. I know it's time for exams in terms, so I just want to make some videos and look at some challenging questions, which I will start with question 2. So this is our question 2. What I want you to do is just try to pause your video and try to copy this question. Try to copy this question as it is. Pause your video and copy it. This question 2, my main focus is on this part. Most of learners have got a problem in calculating the normal force when there is a non-horizontal force like this one, which is not vertical. This force has got two components, the vertical component and the horizontal component. So I want to focus mainly on how we can calculate the normal force here and how to attempt this question 2 in general. So here are the steps that we should follow when we are attempting question 2. Question 2 normally in our caps it's for Newton's laws. So we should be able to state the Newton's laws, the first, second and third law. The other technique that you need to master is how to draw a free body diagram or a force diagram. So this is how we represent a body if we are drawing a free body diagram. This is how we represent the body when we are drawing a force diagram. For question 2, you should be able to use this expression of net force. It's there in your formula sheet. F net is equals to MA. We can calculate the net force for the vertical forces, net force for the horizontal forces, net force on an incline like this. So now you should know that the net force, which is same as MA, if it's a sum of all forces acting at a point, add all forces in this direction. So this is how we should attempt question 2. We should be able to draw the free body diagram and also be able to use the expression of net force. Now the next part of question 2, if we are not given the normal force, we might be asked to find the frictional force. But once you are given the coefficient of friction, so it means you would need to know the normal force so that you can calculate friction using this small formula. So this is your question 2. This is what you are expected for question 2. The other part, which you are supposed to know about question 2, is the universal law of gravitation and how to apply it. This is the law mathematically. You should state it in words. The universal law, where we say the gravitational force acting on two bodies is directly proportional to the product of magnitude of masses and inversely proportional to the square of distance between the masses. In this case, G is equals to Gm over d squared. Memorize the law of gravitation. So I want to quickly go through question 2 and all these steps and what we are expected of on how to attempt question 2. I will use this as my question. But first of all, as I said, I need to focus on how to find the normal force on this diagram. That will be my main focus. Then after that, I need to go through the whole question. Then we'll answer the other questions pertaining to this question. That is from 2.1 to 2.4. So how to calculate the normal force if there is a non-horizontal and a non-vertical force, like in this case. This will be my main focus, and I know most learners have got a problem in that, but I'll do that in the next video. For now, let's go through the steps. The first question, the normal force is needed to calculate the frictional force. In most cases, you need to calculate friction and you need to know the normal force if you are given the coefficient of friction. Calculating any force, e.g. normal force or tension, draw a free body diagram and label all forces. That is the first step in every question. We need to draw the free body diagram. Then for this question, we have got 3 kg and 1.5 kg. So I'll draw the free body diagrams for you so can you try to draw the free body diagrams first, then I'll show you the free body diagrams. Then the next thing is to use the expression of net force. Identify all forces, write an expression of net force. Remember, MA is equals to F1 plus F2 in any direction. So we'll go through all those steps, each step by step. If there are non-horizontal forces, we need to resolve them. So we'll go through the steps on how to resolve the force, then we calculate the normal force. So in the next video, we'll look at how we can calculate the normal force when we have a force like this one, which is not vertical, which is not horizontal, where the force has got components. So that will be the next video. Thank you very much. Let's meet in the next video. As you go through this question, you can try to answer it. I'll go through each and every question. This is our question 2 in our CAPS National Senior Certificate exam. Thank you very much.